Today we're going to be talking a lot about angles, different terminology, different pictures, and just everything that we can think of about angles. And to introduce us to this, I've got a picture for you. If all you're seeing is soda, you're not looking quite carefully enough. Look down at the bottom of the picture by the white. Do you see him yet? This artist likes to place himself in his artwork, and you can see right here are his feet, and then there's his legs, comes up, there's his shoulder, and there is his face right there. So he likes to kind of play chameleon or camouflage himself in his different pieces of artwork. So first of all, let's talk about angles. With this picture right here, we've got three different angles that are going to show up. And you would name those as follows. We would start with angle MNP. This little symbol right here means angle. So I've got angle MNP, angle ONP, and angle MNO. If you'll notice, each one of these angles that I have labeled all have N in the center, and that's because N is our vertex. When naming angles, you always want your vertex to be in the center. We're going to look now at the angle addition postulate. And if you'll recall from last time, we talked about the word postulate, and postulate just means something that we just accept as fact. So for the angle addition postulate, we've got the measure, that's what this M stands for, the measure of angle RST is equivalent to the measure of angle RSP plus the measure of angle PST. So, like I said, this is kind of one of those duh things. Well, of course, the big angle is just going to be the two smaller ones added together. But in geometry, we have to state things like that. So this is the angle addition postulate. And we can use that angle addition postulate to help us find other things. For example, if angle PRT is 81 degrees, angle TRS is 42 degrees, we then know that the larger angle, angle PRS, that the measure of that angle is going to be equivalent to, let's see, 81 plus 42, let's see, 2 and 1 is 3, 8 and 4 is 12, so that's 123 degrees. Example 3, if the measure of angle XYZ is 72 degrees, find the measure of angle XYW and angle ZYW. Again, notice that Y is in the center because it's the vertex for each of these three angles. So all we're going to have to do for this, I know that angle XYZ is 72 degrees, and that's going to equal those other two angles added together. So the first angle is 3x plus 6 degrees. The second angle is 2x minus 9 degrees. So now we just have an algebraic equation. Finish this one on your own. Combine your like terms and solve for x. Pause your video at this time. You should have gotten an x value of 15. But wait a minute, x equaling 15 degrees? That doesn't yet answer our question. What we want to know the measure of these angles. So I'm going to take this 15 degrees for x and substitute it in for both x values to find my total degrees. So angle, let's see, the measure of angle XYZ is going to be, let's see, 15 times 3 is 45. 45 and 6 is 51 degrees. Then the measure of angle WYZ, or you could label that as ZYW, either way works, is going to be 15 in for X. 15 times 2 is 30. 30 minus 9 is 21 degrees. And you would write it just like this, with slightly better degree symbols there. Some more definitions. Congruent angles. Congruent angles are two angles that have the same measure. And we talked about congruent line segments the other day. Same type thing. Congruent angles, you're going to use that congruence symbol. You can say that angles have equal measures, but to say they're congruent, you have to use the congruent symbol. Angle bisector. Angle bisector is a ray that divides an angle into two congruent angles. So this line BD is splitting angle ABC in half. So angle ABD is congruent to angle DBC, or their measures are equivalent. Complementary and supplementary angles. We dealt with this in the past, but let's refresh on it. Complementary angles are angles that add up to 90 degrees. Supplementary angles add up to 180 degrees. And the way that I used to remember this when I was younger, I used to think about the dictionary. C comes before S in the dictionary, and 90 comes before 180 when you're counting. So that's the way that I would keep complementary and supplementary straight. C comes first, so does 90. S comes second, so does 180. Adjacent angles. Adjacent angles are two angles that have a common vertex and side, but no common interior points. So that would be something like this. Angle 1 and angle 2 are adjacent angles. They share a common vertex, or this point here. They have a common side, this side here, but they don't have any common interior points. And what's meant by common interior points, that would be if you had something like this. You can't say that this angle is adjacent to this angle. Even though they are side by side, you can't say that they're adjacent because they share all this common space in the middle. So these are not adjacent angles, but these are. Line segment MN bisects angle PMQ, and angle PMQ equals 122 degrees. And we need to find angle PMN. Find the measure of that angle. So let's see. M is in the center for all of these, so I'm going to label my vertex M. MN bisects, so this is going to be ray MN here. So let's see. That means one of these is P and one of these is Q. Now, of course, when you're drawing these, make sure that these are, in fact, rays and that you extend out forever and ever from these places or from your vertex of M. So let's see. PMQ is 122 degrees. And MN bisects it. Well, bisect, that just means it's cutting it in half. So that means I'm going to have 12 divided by 2 is 6, 2 divided by 2 is 1. Each of those angles will then be 61 degrees. Skip example 5 right now. We're going to come back to it in just a little bit. Another definition, linear pair. A linear pair is two adjacent angles whose non-common sides are opposite rays. Lots of words there. Let's figure it out. Remember opposite rays. This right here would be one ray. Its opposite is going to be on that same horizontal line, but it's going in the opposite or the other direction. So those right there are opposite rays, and they're adjacent angles. So two adjacent angles whose non-common sides, so not this side that they share, but the non-common side, are opposite rays. Vertical angles. Vertical angles are two angles whose sides form two pairs of opposite rays. So we've talked about this in the past, where vertical angles make a V. So there's angle 2, and it kind of makes a V if you flip it upside down, or a V pair with angle 4. So angle 2 and angle 4 are vertical pairs. So are angles 1 and 3. They're opposite sides of each other. So angle 1 and angle 3 are another pair of vertical angles. That's it for today. You have 3 problems to try on your own. Make sure to get these done and bring them in. We will discuss those first thing tomorrow in class.